Hello guys, good afternoon. Welcome again on this channel. Let's start today's class. And first, change the color of the pen. Mm, Okay, let's start now. In today's class, what actually we will learn? We take some topic from mathematics. These are useful for to understand the physics in a future course. Okay, and good afternoon again. Welcome, guys. And we take three topics. Like the first, write the name of the topic, that is differentiation, and a third is the integration. Second is the integration, and fourth is a vector. First, you have to understand what I focus on this topic. Okay, these topic are so fundamental for to understand the physics, and these are the pillar of to understand the physics. Okay, without it you cannot move forward. Okay, and in today's class, in today's session, I will discuss on differentiations, and I'm trying to we are trying to understand how to visualize the concept of differentiation, and how to apply the concept of differentiation in practical life, and these how to derive the formula for differentiation, what is the general formula for differentiation, or what is the mathematical meaning of differentiation. These type of question I'm trying to answer it. Okay, and let's start a differentiations. Okay, let's start a differentiation or differentiations. Okay, differentiation. I think you know about a differentiation. First, we focus on the word differentiation. The meaning, after analyzing the word, we comes in your mind. The differentiation is something is a difference between physical quantities. You also can say change in a physical quantity. What will be the change of physical quantity? Okay, let's try to understand. Simply a differentiation gives a change in a physical quantity with respect to another physical quantity. Okay, it's give a change of physical quantity. Okay, with respect to another physical quantity. Okay, let's take example. By using this example, we will try to understand. Uh, okay, first, I think in a market you went for to purchase and to buy something, potato and fruit vegetable, and what you feel. I think all of you feel this all you feel this incident and this moment. Okay, what actually you observe in that time, uh, actually you feel that the price of potato, like we make it two column, two row. Price of potato and is a time. I think you know the price of potato changes with time. Okay, like at 9 o'clock, the price of the potato is 10 rupees per kg, and 10 o'clock, the price of the potato reduces to 8 kg, 8 rupee per kg. Okay, and as days goes down, going on, the prices reduces simultaneously. Okay, I think you experience this moment, and you experience this incident, and 10 a.m. This is 12 a.m. 6 kg, 6 rupees per kg. Okay, I think you experience this incident. Okay, now the question is that our interest to find out the change of the price with respect to change of time. Okay, let's take example. Our interest to find out how how much change we should do. That's why the price changes accordingly. Okay, like you can say our interest to find out a delta price of potato dealt upon time. You can say this is the a basic of a differentiation. You can say uh, price of potato final price minus initial and time t final minus t initial. Okay, when we put a limit on this mathematical equation, when we put a delta t tends to 0, when we take a objective interval is so small, for that we can say the delta p by delta t becomes a dp by dt, dp by dt. When you also can say the del p by del t and a limit del t tends to 0 is equal to dp by dt. It's give a change of a p with respect to time at an instant. This is the main thing. It's give a instantaneous value. Okay, because some of the students they don't know what gives the del p upon del t. Okay, I'm trying to explain. Okay, let's take another slide. Let's take another slide. And this is the meaning of a differentiation. You can say like you can say if you know ki if you know like if one function is given ki price of a potato changes like this 100 time t. Okay, and now the our interest to find out del p upon del t. Okay, how to find, how to calculate this mathematical parameter. This is a main question, and afford this and to find out this calculation, to solve this operator, some mathematical formulas uh, are there, and we have to memorize these formulas, because and these formulas can be proved by using first principle of mathematics, first principle of differential. Okay, and like I also introduce the first principle of differential. We have a function, y is a function f of x. Okay, and now our interest to find out what uh, change will be when we change the value of x with x plus del x. You can say this final value of function becomes y plus a del y. Okay, and this is the equation first and this is the equation a second, and subtract equation 2 to 1, and this is a delta y is equal to fx plus a del x minus fx. Okay, and divide by del x and divide by del x divide by del x. Okay, and put a limit del x tends to 0, fx plus del x minus fx del x. It's give a dfx upon dx. Okay, and it gives a differentiation at a x is equal to x. It is a instantaneous, you can say it at a particular space. Okay, these are the fundamental of differentiation, and by uh, solving this equation we find out some formulas, and i I write first is what is the differentiation of this del x a raised to power n x raised to power n. Okay, a and are the constant. Okay, a x and minus 1. Okay, this is some general basic formula you can memorize. And some other formulas uh, is also there. And you can for this formula you can refer NCERT book. Okay. And uh, let's take uh, let's take move let's come to the application part of a differentiation, because how now the question is that how to apply the concept of differentiation in a physics. Okay. Because it's a so important thing for us. Okay. By giving some example, I'm trying to explain you. Let's change the slide. Okay. First thing is that how to understand, how to apply, like when we deal with a change in a physical quantity with respect to another quantity. and and our focus is to find out instantaneous a particular at a particular instant. Like you can say, when we deal with a continuous function, in that time uh, comes the concept of the differentiation comes into the picture when we deal with a continuous function. Okay. Like change follow a particular function in that time, and our interest to find out how much change will be at a x is equal to x is equal to 2. And now we can find out some other parameter. Like let's take example. What is the what is the acceleration? Acceleration is equal to del v upon del t. Okay. This is a definition of average acceleration. We will discuss later in mechanics. And but our interest to find out a instantaneous, what we will do, we take a differentiation del v upon del t at a t is equal to t. And by using the we can find out uh, acceleration at any instant. Okay. Like we the function is given to you, v is the 10t square, and our interest to find out dv upon dt at a t is equal to a 2 second. What will the value of acceleration at a t is equal to 2 second? How to find out? A is what? Del v upon del t. Del t 10t square, and 10 is a constant. It comes out of the this operator. And t square, what is the definition of t square? 2t. And you can write 20t, and at a t is equal to 2, 20 into 2, a 40. A 40 is the answer. Okay. Like you cannot find out by using this del v upon del t, because it's give a average picture of any function. Okay. That's all from my side, and we will meet again in your next lecture. Thank you. All the best.